What's up, guys? In this video, I want to go over the top mistakes that I see students make with linear equations as well as inequalities. When students are taking a test or they're doing their homework or maybe just some classwork in class, these are the most common mistakes that I would see students make. Now, again, a lot of these are going to be simple, but some of them are going to stem from a misunderstanding of the information. That's why I want to make sure I highlight these mistakes for you. So therefore, if you're just trying to review, or maybe you have a test coming up, you're going to have a little bit of a leg up. Now, more specifically in this video, we're going to talk about solving linear equations, evaluating expressions, solving linear inequalities, modeling equations, solving absolute value equations, as well as solving absolute value inequalities. So we're going to focus on the mistakes that students make because I do not want you to make those same mistakes. Let's get into it. Okay, so this is a very basic equation, but this mistake happens if it's like a basic equation or something more advanced. A lot of times students are just kind of going through the motions and they just kind of like totally forget to use your parentheses. And one thing I always tell my students, when we are evaluating expressions, just use parentheses. It literally takes just a couple extra seconds. But I'm telling you, when you're taking a test or you're trying to do your homework and you're trying to do things quickly, or maybe you're making a video and you're talking while you're doing it, these mistakes happen. I have made this mistake multiple times before. So to avoid making this mistake, I just use parentheses. So we have the expression x squared minus 3, and we want to find the value of this expression when x is going to equal to -2. So most students don't have a problem with. They say, all right, so we're going to replace our x with a -2. So we're going to go ahead and plug it in. Now let's go with the mistake where students will make if they don't use parentheses. Okay, so a lot of students will just go through this, like, why am I going to waste my time? Go ahead and using parentheses. And then if they might be thinking clearly or maybe not thinking clearly, and they say, well, I can just square the 2. 2 squared is going to be 4, and then multiply that by a negative. So therefore, it's a -4 minus 3. And then -4 minus 3 is going to be a -7. Unfortunately, ladies and gentlemen, though, that is incorrect. We need to make sure we're applying the parentheses. When we are evaluating this x for -2, the whole thing, not just the 2, but it's also the -2. So this is actually a -2 squared minus 3. Now remember, when something's squared, you're multiplying by itself. So a negative times a negative is now going to be a positive. So therefore, -2 squared is going to be a +4 minus 3, and that is going to equal to 1. That is going to be our correct answer. Okay. So now let's go and get into another expression. And a lot of times students will, they say, oh, okay, I'm going to have the power. I'll make sure I'll use parentheses there, but I'm not going to worry about it any other time, right? So they see the -2 and they're like, all right, well, -2 cubed, maybe I'll just do that in my head. -2 times -2 is a +4, but then multiplied by -2 is going to be a -8. -8 times 5 is going to be a +40. Okay, good. I got that one. Now, this mistake happens not just on a basic problem like simplifying expressions. I see students make this all the time. They see a -x, and they see here we have an x equals like a -2. Oh, it's already negative. So they just put in like the -2. No, that's not what that represents. But anyways, they get the answer of 38. And ladies and gentlemen, that is going to be incorrect. Well, let's leave that as an equal sign. And then they say the answer is 38. No. So when you have a negative of a variable and you're plugging it in, it doesn't just mean take the negative value of that. No, what it's saying is subtract whatever's x. Again, go back to your use of parentheses. So we have a -5 times -2 cubed, right? Which is going to still give us 40. We got that. But this is a minus a -2, right? Utilize the parentheses. This is minus our x, and x has a value of -2. So we're still going to get 40 here. That's good. But then this is a minus a negative, which is going to turn to a positive. So it's going to be a +2. So our final answer is going to be a 42. Okay, so this one is going to deal with a fraction. And I think we can all agree we don't like fractions, right? But this is a two-step equation. It's like simple enough. Most students like recognize, all right, I have a 3/7 times x plus 2. I know the first thing that I need to do is subtract the 2, and I'm going to do that on both sides. And therefore, I'll have a 3/7 x is going to equal to a 15. But then at this case, students they hate fractions. They're like, I don't know what to do. Like sometimes when it's like an easy problem, like a 3x plus 2 is equal to 17, they get that. They subtract the 2 on both sides. You get 3x is equal to a 15. And then you divide by 3. X equals 5. But it's something about fractions that just, I don't know, it just messes everybody up. And then they might say, well, I don't know, this is a fraction. So a lot of times I'll just see students like just totally freeze up and maybe try subtracting on both sides. So they get a final answer of x equals a 15 minus a 3/7. And no, ladies and gentlemen, we need to understand that to isolate this variable, we need to use those inverse operations. But sometimes when we have fractions, don't just try to make things up like, how can I get rid of this fraction? Well, if I subtract a 3/7, then that's going to go to 1. No, that's going to go to, well, first of all, you can't even subtract them because they're not even like terms, right? So we got to think, how can we get the coefficient of our variable to be 1? Now, yes, you could divide by a 3/7 on both sides. And if you remember, dividing fractions is the same thing as multiplying by the reciprocal, right? But again, sometimes students still get kind of mistaken with that. So what I always like to teach students whenever we have a fraction is think about what is the number that we can multiply by, right? Because here I have a 3/7. And what you can think about doing is like saying, all right, this is technically being divided by 7 and being multiplied by 3, right? Because I can rewrite a 3/7 or 3/7 x is the same thing as a 3x divided by 7, right? So it's very important to understand. So you could apply the operation separately. You can multiply by 7 on both sides, then divide by 3. Or if you can think about this, if I say 4/3 times 3/4, that is a fraction multiplied by its reciprocal. What is a fraction or a number always multiplied by reciprocal going to give you? It's always going to give you 1. Remember, that is our goal. When we're trying to solve a linear equation, we're trying to get our variable to have a coefficient of 1. So yeah, using inverse operations is easy a lot of times when we have simple numbers, but sometimes when we get a fraction, it gets confusing. We start making mistakes like subtracting on both sides when it's actually multiplied. We don't want to do that, right? But so what I want you to think about is say, all right, what I can do here then is if I have a 3/7 x, what would be the reciprocal of 3/7? And if you're thinking in your head that's going to be a 7/3, well then you are correct. So in this case, I have a 3/7 x equals 15. I know I need to get this to 1. So what I'm going to do is I'm going to multiply by a 7/3. Multiply by 7/3. Now again, students will still get mistaken here. How do I multiply a fraction times a integer? Well, the same thing. You know, subtracting a whole integer from a fraction, that can be confusing as well. So the important thing is we know this is going to give us 1. Now again, the integer can always be rewritten as 15/1. I can divide this 3 into the 15 5 times. So my final answer is going to be 5 times 7, which equals 35. Here's another one with fractions, and what do you know? That's where mistakes happen. Now, a lot of times once we learn how to deal with fractions, we learn about getting rid of the fraction. And you can actually definitely do that in this case as well. It might not be ideal though, because if you're wanting to get rid of the 7 in the denominator, you'd have to multiply everything times 7. And yeah, for mental math, it's not horrible. But again, if you're taking a test, it's adding in a lot of times where you can make some mistakes. Whereas this problem's not that bad. I would say, yeah, get rid of the fraction, right? So to get rid of fraction when you have multiple denominators, you got to multiply by the least common denominator. That is going to be the smallest number that both of your denominators evenly divide into. And in this case, you can hopefully see that that least common denominator is going to be 10. So what students will do, or the mistake that students will do, is they will sometimes just multiply the 10 on the left-hand side, or they'll say, I know I need to multiply by everything, but they will forget to multiply across. And ladies and gentlemen, I make videos every single day. I'm always talking when I'm doing my math, and I will tell you, I make this mistake a lot. I know I need to multiply by everything, but I just forget to, right? So 10 times 1/5, again, the 5 divides into the 10. You can think about that as 10/1. So that's going to be a 2. 2 times x is a 2x. And 10 times 1/2, hopefully you recognize is going to be 5. And then students will make this mistake of forgetting to multiply by 10. Don't do that, right? Make sure, draw these parentheses, draw the distributive property, and double check your work. Just go down a little slower, right? Because it's so frustrating to know what you're doing, but to make this mistake. So the correct answer is a 2x plus 5 is equal to a 10. Now I can use my inverse operations. 2x is equal to a positive 5, divide by 2, divide by 2. X is going to equal a 5/2. Okay, so this example, we have a linear equation, and we just need to solve for y. Now, this is pretty much a routine problem that students are going to be doing over and over and over again. I don't care what class you're in, if you're just beginning it, or maybe you've been doing a lot of math. This is a problem that we commonly have to do over and over again. And usually students kind of understand, all right, I need to isolate the y, so I need to undo what's happening to the y. I see that's going to be a subtracting 10x, so I need to add the 10x to the other side. So usually everything is like, okay, and the problem I think that students will make with this problem, that's a positive too, is sometimes they're just not thinking. They're just kind of going over things, like going through the motions, and they're just not careful. So the last step is like 5y, and you're like, all right, just divide by 5 on both sides, right? And so they'll divide by 5, And what happens here is they say like, oh, well, I know 10 divides into 5, right? That's just going to give me a 2x. And sometimes they'll even forget that the 5 divides into the 2, or they recognize that's a fraction and they just don't want to deal with the fraction. So then they hope their teacher like is not paying attention and be like, well, how about I just write a 2x plus 2? And sometimes that's the problem of us teachers. We always, or in even textbooks, we're always so used to having like integers or nice fractions that students are like, something might be wrong. I'm just not going to write that as the answer. And hopefully that, that looks better than dealing with fraction. Unfortunately, ladies and gentlemen, that is incorrect. When I have an expression separated by addition or subtraction being divided by a value, this 5 is divided into both of these terms. So my final answer is going to be y equals a 2x plus a 2/5. Make sure you distribute this 5 to both of those terms. Okay, now the next one is, again, going to solve for y, but you can see we have 2 different y variables. And typically when we're solving like linear equations, we always talk about like combining your like terms. Unfortunately, in this case, we can't combine like terms because you can see this y has a 4 being multiplied by it, and this y has an x being multiplied by it. So again, students are kind of like, hey, you know what, maybe I'm just gonna do what I know how to do and just hope my teacher is like not paying attention and like grading late at night or something. So they say, well, I'm gonna solve for this y because that's the easiest one. So they'll add the xy to the both sides, and they get a 4y equals xy plus 8, and then divide by 4, and like say y equals, let's say, 1/4 xy plus 2. Looks really good, but unfortunately, ladies and gentlemen, that is incorrect. When we're solving for a variable, we can only solve for one of those variables, right? So what other techniques can we do? Well, if we had something like quadratics, right, we use that process to factor to be able to then apply the zero product property so we can solve for one variable at a time. We don't have a quadratic here, but actually factoring is still going to be, our method. See, if you look at these 2 expressions, you can recognize they both have a common y in common. So what I can do is just like kind of how this 5 was divided into both those terms, I can take these 2 terms and I can divide out a y. When I divide out a y, I'm going to rewrite the expression as a product or a multiplication. So if I divide out a y, both these terms, I'm going to be left with a 4 minus an x. Now again, this still gets confusing for a lot of students. So I just want to explain to you, all I'm doing is I'm reversing the distributive property. If I take this y, again, this is multiplied. Y times 4 is 4y. Y times negative x is a negative xy. So all I'm doing is I'm taking this expression, by factoring out this y, I am rewriting the expression as a product. But the value of this expression and that expression is still going to be the same, right? I didn't change the value of the expression. Now, though, to solve for y, I see that y is multiplied by 4 minus x. To go ahead and solve for this, then I'm just going to subtract the expression of 4 minus x, and I get a final value of y is going to equal a 8 over 4 minus x. Okay, so what we're trying to do is we're given this piece of information and we want to go ahead and rewrite the equation in y equals slope-intercept, or y equals mx plus b, which is going to be our slope-intercept form. So we have a table of values, right? We have our x values, we have our y values. We need to write it into this form. Now, a lot of students remember m as the slope and b represents the y-intercept, but a common mistake that I see students will do is they just kind of like mix things up, right? So what they might do is they might take this and say, well, 75, that is going to be our x-intercept, but let's write it as, unfortunately, with our m, and they can flip-flop the slope and the y-intercept. And they recognize here that this is going down by 10s, so therefore that would be a subtract 10. And unfortunately, ladies and gentlemen, this is incorrect. So they have the correct idea, right? But the y-intercept, remember, is when x is going to equal to 0, and that is going to be your b. So if I was going to write this correctly, I know that when x equals 0, that's going to be my y-intercept. This is going to be my b. So I'm going to have a plus 75. Now, they had the correct idea. They understood that the values are going down by 10. And again, this is very important because my x values are going up by 1. So we can see between each of these values, we want to see what the change is between my y values. And since the change here is going to be a 1, my y values, you can see, are going down by 10. So that is going to represent the slope. So that can be represented as a negative 10x. Okay, now the next mistake happens a lot. And it happens because students understand, maybe they make this mistake, maybe they don't, but their teacher teaches it and they're like, okay, I got it. I'm gonna just be careful. I understand slope-intercept form. I know that b always represents the y-intercept, and that means when x is equal to 0. So they go to find x equals 0 and they say, I got it. Y is going to equal, or b is going to equal to 7. Done. not going to make this mistake again. And then they go to it, they say, all right, well, now let's go and look at the change in the y values. And they recognize, all right, this is going down by 10s. So again, they immediately look over here and they say, hey, this is going up by 10s. So then they say, well, that means the slope is going to be a positive 10. X plus 7. And unfortunately, ladies and gentlemen, that is incorrect. The reason being is because, yes, the y values are changing by 10, but they're not changing by 10 for every x value that's going up by 1. They're changing by 10 as x is changing by 5. Remember, the slope is the change in y over the change in x. So when you have your change in 1, it doesn't, you just look at the change in y. But when your change of x is not 1, you need to take that change of y and divide it by the change of x. So the simple thing we need to do is just take 2 points. Usually it's like your first 2 points, or any point that has like a 0 is usually going to be is best. So remember, that's a change in y over the change in x. So what I can do here is I can take a 17 minus 7, and then I can do a 5 minus 0. Well, 17 minus 7 is going to equal a 10. 5 minus 0 is going to equal 5. That's going to give me a slope of 2. So the slope is 2, not 10. You got the right y-intercept. Just be careful. Only look at the y values, or only find the difference of the y values when the change of x's is going to be 1. So this one will be a little tricky. It can catch students a lot of times off guard. So my final answer is going to be a 2x plus 7. Okay, so it's a fairly straightforward inequality here. Nothing crazy going on. 2x plus 8 is less than or equal to 6x minus 4. Now, the reason why students will make mistakes here is, again, they kind of let their guard off. They're like, all right, this is a basic problem, right? Solving inequalities is just like solving equations. So let's just go ahead and get the x to the left-hand side, use my inverse operations, and I got this one. Maybe it's a test and you're feeling confident and you're like, I got this one. So I get a negative 4x plus 8 is less than or equal to a negative 4. They subtract the 8 on both sides. Negative 4x is less than or equal to a negative 12. They're like, all right, just got to go ahead and divide, and we're all good to go. X is going to be less than or equal to a positive 3. And unfortunately, you get it wrong, right? And a lot of times we get it wrong because we're just not thinking. Maybe we're talking as we're making a YouTube video. I don't know. It happens all the time. I have made this mistake multiple times. Sometimes you see this answer choice on your test, and your brain just immediately gravitates to it, and you select it. So it's very, very important. The mistake was made, ladies and gentlemen, because whenever you are dividing, when you're trying to solve an inequality, and you are multiplying or dividing to isolate your variable, but by a negative number, you need to make sure you flip the sign. So the correct answer is going to be x is greater than or equal to a positive 3. Okay, now on the next one is probably just one of those simple mistakes, but it happens all the time. Students have this ingrained, and because as teachers, we really stress it. Whenever you multiply or divide by a negative number, flip the sign. Flip the sign. It's a common mistake, but students will still just make it, right? But sometimes students will make this mistake our students will still make a mistake related to it when you're actually not multiplying and dividing at all, right? We need to solve for x, right? So sometimes students will do is they say, uh-oh, I see a negative. And immediately once they see the negative, they just get triggered. I'm going to go ahead and flip the sign. And they just go ahead and do it for a subtraction. And unfortunately, ladies and gentlemen, no. The rule for flipping the sign only applies when we're multiplying or dividing by a negative number, not subtracting at all. So in this case, all you simply need to do is just like what you had. You had everything right. Just go ahead and subtract the 3x on both sides, but you don't need to flip the sign. 10 is going to be greater than a 2x. Divide by 2, divide by 2. 5 is going to be greater than x, or you can rewrite that as x is less than 5. Okay, so everything's pretty straightforward. We have absolute value of 5x minus 9 equals x plus 3. Now remember, when solving an absolute value equation, like I have x is going to equal to 3, it's important to understand that we have two different options, right? X could equal a negative 3, because the absolute value of negative 3 is still 3. Or we could have x is going to equal a positive 3, because 3, absolute value of 3, is also equal to 3. So we need to take two cases, the positive as well as the negative. But that's where the mistakes happen out. So the first one is pretty straightforward. You just rewrite the expression or the equation without any absolute value symbols. The next one is where students will make their mistake. They know they need to negate it. We got to look for this negative solution, but rather than negating the whole expression, they just negate the x, or maybe they just negate the 3, right? But again, it's important, ladies and gentlemen, you can't just negate an x, right? This is a negative times the whole side, whatever is on your right-hand side. So put parentheses around it and understand you're negating the whole right-hand side, whatever it may be. In this case, it's x plus 3. So you're going to have to distribute. So this is a 5x minus 9 equals a negative x minus a 3. Now we can go ahead and solve this absolute value equation by solving each of these linear equations separately. So I can just subtract an x on both sides. So it's a 4x minus 9 equals 3. Add the 9 to both sides. 4x is equal to a 12. Divide by 4, x is equal to 3. Over here, I'm going to add the x to both sides. I get 6x minus 9 is equal to a negative 3. Add the 9, 6x is equal to a positive 6. Divide by 6, x is equal to a 1. OK, now the next mistake comes in. Students are like, all right, I'm not going to make that mistake again. Like the ears are perked up. Like, OK, I got this. I have to set up or create my two cases. I'm not going to make the mistake. I'm going to make sure I negate this correctly and properly. So that's a negative 3n plus 1. I got it. Now I just need to go ahead and solve. Now in this case, I'm going to solve for the n on the right-hand side because I just don't want to create some negatives, right? That's going to add to my work a little bit, and sometimes I can make that mistake. So I divide by 2, I get negative 3 is equal to n. And then over here, what I need to do, I'm going to do the same. Actually, in this case, I'm going to add the 3n on both sides. I'm going to add the solve for the n on this side because I like when my n is positive as well as on the right-hand side. So I add a 7, I get 4n is equal to an 8. Divide by 4, n is equal to 2. Now, these are two integers. We love integer solutions, right? And if we were taking on a test, this more likely than not would be an answer choice. So a lot of times students see the answer and they're like, oh yeah, that's it. Got the answer right. Unfortunately, this is wrong. Why is it wrong? Because n equals negative 3 is what we call an extraneous solution. Yes, it's a solution to this linear equation, but it's not a solution to the original equation. Well, how do we know? Plug it back in. When I take negative 3 and plug it back in, I get negative 3 minus 7 is a negative 10. Absolute value of negative 10 is going to be a positive 10. 3 times negative 3 is a negative 9. Negative 9 minus 10 is going to equal a negative 10. 10 does not equal a negative 10, so therefore, ladies and gentlemen, this is extraneous. So I have absolute value of 16 minus p is greater than a 3. Now, it's very important when we are looking at the greater than symbol, what we're going to do is we're going to create a or compound inequality. Now, a or compound inequality, what that means is our two solutions is going to be one could be true, or the other could be true, or both, right? It's what we call an inclusive compound inequality. So when we have the or, we're going to create two different statements. I'm going to say 16 minus p is greater than 3, or 16 minus p is less than a negative 3. Now I'm just going to go ahead and solve them and graph them on the same number line. But it's important. They don't need to intersect. They can go in opposite directions. That is going to be perfectly fine, as long as our solution just needs to satisfy one of these inequalities. So by going ahead and solving, I'm going to subtract a 16 on both sides. Negative p is going to be greater than, let's see, a negative 13. Divide by negative 1. Make sure to flip the sign. P has to be less than a positive 13. And then over here, I'm going to again subtract the 16 on both sides. Negative p is less than a negative 19. Divide by negative 1. Again, I'm going to flip the sign. Now, if I'm going to go ahead and graph this on a number line, I don't know why I did a line here. Let's say here's 13. Let's say here's a 19. P has to be greater than 19, right? Not included 19, but greater than. So it's going to look in that direction. And then 13 has to be less than, so therefore it's going to go in that direction. So again, to satisfy this absolute value inequality, the values either have to be less than 13 or they need to be greater than a 19. So just make sure you understand what you're looking for and understanding this is a or inequality. OK, now the next one comes into when we have an and inequality. This is very different than the or inequality. The or is either one or both could be true. For an and inequality, they have to both be true. Now, while you can recreate this as two different inequalities, the mistake that students will make is usually doing that. And then you're solving twice, and it's kind of annoying. The easiest way to be able to solve a problem like this is, again, since we're looking for the intersection of these two solutions, is just to use a compound inequality. So all I'm simply going to do is take a negative 7 is going to be less than or equal to a 4y minus 9 is going to be less than or equal to a 7. So all you simply do is take the same sign, rewrite it in front of your expression, and then take your whatever it's equal to and negate it. Now I can just use my inverse operations once, and I don't have to worry about doing it both times and trying to figure out everything from there. So therefore, that's going to be a 16. Now I can divide by 4. You just divide by 4 on both sides of your inequality. And in this case, I'm going to get a 1/2 is less than or equal to a y, which is less than or equal to a 4. So now when I go on my number line, I have here's 4. let's say here's 0, so there's 1/2. And again, y has to be greater than 1/2, greater than or equal to, so I'm going to fill it in. And then here, y has to be less than or equal to 4. So again, fill it in, and it's going that way. But again, it's not an or statement. We're looking for the intersection. Where are the only values that both of these inequalities are going to be true? That is going to be between the values of 1/2 and 4. Now, if this video was valuable for you, I know you're going to love the next video I have for you now. Cheers.